Welcome to the deep dive. Today, we're getting into the weeds of prompt engineering. Definitely moving past the basics, most folks know.
That's right.
Our focus is really on, the strategy behind picking and mixing prompt patterns, how to get those top-tier results for complex stuff.
Exactly. And we're leaning heavily on insights from the prompt pattern playbook and some related research here.
Yeah, the aim is to unpack how experts, people already comfortable with AI, can really level up their game. Actionable insights, that's the goal.
It's about being more intentional, almost like an architect designing a system, rather than just throwing individual prompts out there and hoping for the best. Using patterns together unlocks much more.
Okay, so let's start there. Choosing the right pattern. It's not random, is it? The playbook talks about a framework, specific criteria.
That's spot on. It's really about understanding the job you need done. The framework breaks it down into, well, two main areas: task characteristics and domain requirements.
Test characteristics. What falls under that?
So you look at the complexity level. Is it simple, or does it need multiple reasoning steps? Then time sensitivity. How fast do you need the output? Crucial.
Right.
Accuracy requirements are huge, obviously. How critical is it that the answer is absolutely correct? And finally, the output format. What should the result actually look like?
Yeah.
Structure, style, all that.
Makes sense. Retrieving a fact versus generating a whole report, totally different needs.
Totally.
Yeah.
And then you add the domain requirements on top. Things like the technical depth needed, how much expertise does the AI need to access,
Okay.
the creativity level, factual recall, or something more imaginative, who's the audience type. That shapes the language, the tone, and the use context. Where and how will this output actually be applied? Professional setting, academic.
Got it. So analyzing all that up front is step one for picking the right tools, the right patterns.
It's foundational. Without that understanding, you're sort of flying blind when it comes to pattern selection.
So once we've mapped that out, the next step is often combining patterns, especially for trickier tasks. The playbook mentions specific combos for analysis centered around chain of thought.
Yes, exactly. For complex analysis, chain of thought is often your primary pattern. It guides the model through the reasoning step by step.
Okay, the core logic.
Right. But to make it more reliable, you bring in supporting patterns. Self-consistency is a big one. You ask the model to find the answer using several different reasoning paths.
So multiple
Independent attempts.
Yeah.
If they mostly arrive at the same conclusion, your confidence goes way up. Then there's verification. You can do this implicitly via adversarial testing, basically, throwing tricky edge cases at the model to see if its reasoning holds up.
stress testing it.
Kind of, yeah. And you can also use explicit adversarial testing to actively poke at potential weak spots or biases in the analysis it generated.
That sounds incredibly thorough. Can you give us a practical example, maybe something technical?
Sure, let's think about, say, debugging some complex software code with an AI system. You might start with chain of thought. Okay, analyze this code, these error logs, this documentation. What are potential root causes, step by step?
Makes sense.
Then you'd use self-consistency. Propose 3 different debugging strategies based on different ways you could interpret this error. Get variety.
Okay.
To test those strategies, you use adversarial testing. Feed it maybe some slightly weird system state information or an unusual user input that triggered the bug. See if the proposed strategy still makes sense.
See if it breaks.
Exactly.
Yep.
And finally, you look at everything, the different strategies, how they held up under testing, and you synthesize that to figure out the most probable cause and the best fix. It's that mix of reasoning and validation.
Right. It's not just about the answer, but how robust the path to that answer is. Super clear. Okay. What if the goal isn't analysis, but something more creative?
Yeah, creative tasks often call for a different mix. Here, the role-based pattern frequently takes the lead.
Setting the persona.
Precisely. You tell the model, you are a witty travel writer, or you are a formal scientific researcher. That sets the tone, style, even the knowledge it draws on.
And supporting patterns.
Iterative refinement is key. You get an initial draft, then you provide feedback, ask for changes, make this part funnier. Expand on this idea. It's like working with a human collaborator.
Refining it over rounds.
Yep. Few-shot prompting is also useful here. You give it concrete examples. Here are a couple of paragraphs in the style I want. Generate something similar.
Giving it a target to aim for.
Exactly. And sometimes just adding more detail, more sensory information, and follow-up prompts can enhance the richness. It implicitly guides the generation.
So, like, if I wanted an AI to help draft a sci-fi script, I could start with, you're a screenwriter known for hard sci-fi, maybe give it snippets from films as few-shot examples, and then just keep tweaking the dialogue and plot beats it suggests using iterative refinement.
That's a perfect illustration. The role sets the stage. Examples anchor the style. Refinement shapes the final product. Now, thinking practically, time and accuracy often dictate our choices too, right?
Oh, absolutely. Big constraints. Sometimes you need it now, other times it has to be perfect.
For those immediate needs, simple queries, zero shot often works fine. Just give the instruction. If it needs a little logic but still needs to be fast, a simple chain of thought, just a couple of reasoning steps can work.
Quick and dirty, relatively speaking.
Right. But when you have more time, and especially when accuracy is paramount, like in high-stakes situations,
Yeah.
that's when you pull out the more complex combinations.
Full toolkit.
Pretty much. You might start with a very thorough chain of thought, then layer on self-consistency for validation across multiple paths, then hit it with rigorous adversarial testing to find any holes. And finally, iterative refinement to polish and fix anything you found. It's multi-layered for maximum reliability.
So for just general, day-to-day, less critical things, we often don't need all that firepower.
Often, no. For many common tasks, zero-shot or maybe few-shot prompting does the job surprisingly well. Maybe add one round of refinement if the first output isn't quite right. Keep it simple when you can.
Which leads us nicely into implementation and, crucially, quality control. Just picking patterns isn't the end of the story.
Not at all. You need to ensure the output actually meets the standard you need. The Playbook suggests a kind of progressive approach. Start basic, maybe zero-shot.
Okay.
If that's not good enough, add a supporting pattern, like iterative refinement. Still not there.
Right.
Maybe bring in verification through adversarial testing. You layer things on as needed.
Incrementally improving quality and robustness.
Yeah.
What are the key checks for that quality control step?
Several things. You want to check for consistency, especially if you use self-consistency. Do the different paths agree? You absolutely need validation against edge cases. Does it handle weird stuff? Format accuracy, does it match the structure you asked for? And obviously, content correctness. Is the information actually right, factually, logically sound?
So if I were generating technical documentation, I'd check for consistency across sections, test the instructions against maybe an unusual setup, make sure the formatting fits our style guide, and double-check all the technical details are accurate.
Precisely. That kind of systematic check is vital, especially for expert use cases where mistakes can be costly. And speaking of those, we could touch on a few more real-world expert applications.
Yeah, let's do that briefly.
Okay. Legal document review. Chain of thought for understanding the clauses, then adversarial testing to find loopholes or risks, maybe self-consistency for verification. Very powerful.
I can see that.
Software architecture. Chain of thought to outline the system, self-consistency to explore different design options, adversarial testing to see how it handles potential failures.
Designing for resilience.
Exactly. Or think about generating specific instructions. Start with zero-shot, add constraint-based patterns to enforce rules, must use metric units, steps must be numbered. Then iterative refinement for clarity, educational content, maybe task clarification for learning goals, constraint-based for structure, verification for accuracy, iterative refinement for engagement.
And complex decisions.
Yeah, decision-making.
Yeah.
Self-consistency to generate options, chain of thought to analyze the why behind each, verification for feasibility, and adversarial testing to probe downsides. Helps make choices more robust.
It's really striking how adaptable these combinations are. Okay, just to make sure everyone's crystal clear, maybe a super quick recap of the core job of those key patterns.
Good idea. So, role-based.
Yeah.
Adopts a persona, focuses knowledge, task clarification plus desired format.
Yeah.
Gives a structured specific request. Zero-shot. Instruction only, no examples. Few-shot. Learns by example. Input-output pairs. Constraint-based. Follow specific rules you set. Iterative refinement. Improves step-by-step with feedback. Chain of thought. Shows its reasoning, step-by-step logic. Self-consistency. Multiple reasoning paths for validation. And adversarial prompting. Actively challenges the model to find limits.
Perfect. So wrapping this up, the big takeaway for our expert listeners seems to be advanced prompt engineering isn't about finding one magic prompt. It's about understanding these individual pattern tools and then strategically combining them based on the task's specific needs, its characteristics, its context.
You've nailed it. It's about building tailored prompting strategies. The framework and the examples we discussed, they're really a starting point for experts to develop their own sophisticated approaches.
This has been really illuminating. It shows there's a real science or maybe an art to getting the best out of these models at a high level. Thanks so much for walking us through it.
My pleasure. It's a fascinating area.
Definitely. And maybe a final thought for our listeners to ponder. As these AI models keep evolving so rapidly, how might these pattern combinations need to change? What new hybrid approaches might we need to invent to keep pushing the boundaries? Something to think about.